stoichiometry problem solving. Okay, a while ago discussed one problem, small, mouse to ground, or to mole, something like that. But it was more on inorganic, okay, inorganic chemistry. Now it's more on organic chemistry, dealing with hydrocarbons. Okay, as we can remember, hydrocarbons composed of carbon atoms and hydrogen atoms bonded together to make one organic compound. Okay, so we will review basic concepts on hydrocarbons, as you can remember, okay, in our it's part of organic chemistry. I think so, but it's also part in organic chemistry along the last part in the textbooks of chemistry. But specifically, it was discussed also in the organic chemistry. Okay, so we'll review the hydrocarbons, right? The single bond, double bond, and the triple bond, so you can remember. And then if it is a single band, we have the A and E, small letter A, small letter N, small letter E, okay, represented as one singular about double band. It is represented in two horizontal lines, so it ends E. And then if we speak about alkyne or the triple bond, it ends with Y and E. So it is represented by three horizontal lines like this: 1, 2, 3. But somewhere along the way, actually, if you will add hydrocarbons to other aromatic hydrocarbons also, right? Such as the toluene, the benzene, like those organic compounds that have benzene ring. If you can remember in organic chemistry, something like that. Okay, so A and E will be the single band, okay, and then the alkane family. Okay, double bond is the alkene family. Triple bond is the alkyne family. So, alkane, alkene, and alkyne. So, the example of alkane is methane. Okay, methane CH4, the natural gas, composed of one carbon atom and four atoms of hydrogen. Okay, that's methane. That's natural gas. An example of alkane family. An example for the alkene family will be the ethylene. Ethylene. ETHYL. Is that really short? Let's change another example to make it short. Butene. Butene. Okay, it's not butene. Okay, it's a double band. And then example of the alkane or alkyne. What do you pronounce that for? I forgot. Alkene, right? Alkene family, triple bond. So the example will be example for that is butene. B-U-T-Y-N. Like that, M-C-Y-N, right? I told you before. And then acetylene is an example of double bond or alkene family, I think. Okay, acetylene. Okay, like that. So double bond. Okay. So before going further, and then most of the times, those hydrocarbons will be undergoing the process of combustion. Okay, when we speak about combustion, oxygen will be added to the hydrocarbons. Okay, to produce carbon dioxide and water. So we are referring in this discussion for the complete combustion. We are not referring to the incomplete combustion that during the reaction it will produce carbon monoxide, so unstable. But if it speaks stability, then it will produce carbon dioxide plus water under normal circumstances. Okay, we are referring to And then the examples here in the stoichiometry problems I have in my hand is related to hydrocarbons. Okay, so in order we can solve hydrocarbons combustion, we should have review a little bit to the. So anybody studied organic chemistry? I think so. DS biology course have organic chemistry. The medical technology or the medtech, Bachelor of Science in Chemistry, the SCHEM, have also showed 100% have organic chemistry subject. And the chemical engineering, okay, have organic chemistry. So those are pure sciences courses that deals with the study of organic chemistry. I don't think so in other engineering courses, but I think there are only up to general chemistry 1, 2, 3, and 4, meaning inorganic chemistry. I don't think so, I'm not really sure. Okay, but I think. But it's also discussed along the organic chemistry textbooks, okay, in the first year college, right? As you can remember, the orange book, more like this, the author of the book or the textbook is something like orange color. It's being discussed somewhere in the last portion regarding the topics of organic chemistry. Okay, going back to hydrocarbons, we introduced you the basic formula. Okay, wait. Okay, I will put back the microphone here in a way you can still hear me even though I will not use the microphone. Okay, where's my pencil pen? It's being lost. Okay, my gosh. Oh, really? Oh, here it is. I'm gonna use the green pencil pen because a while ago I used the blue pencil. Color coding. Wow. In organic chemistry, using blue pen. We got color coding chart. Like that. Too much scratch papers. Okay. Like that. Okay, wait for a while. Need to verify if it is really correct because that was a long time ago. Okay. Yes, maybe it is not correct already. Okay, because that was 20 years ago in my college education. This is only stock knowledge, and I don't know if it is really correct or not. But it can be proven also if you atoms, how many carbon of hydrogen, and then you try to equate that in the actual form A and E family hydrocarbons. Example, methane, butane, propane, like that, right? Okay. So CN, alkane family. Okay. I will write alkane be represented single band, something like this. Okay. So the N plus 2. Okay, this is it. We will try to prove that one. Then if it is not correct, then we can change. Okay, because somewhere along the discussion, we need to change. The important is we have to analyze. Okay, though we memorized the basic formula, then if it is really wrong, it's a long time ago, then we have to prove and then change it in our analysis right now. Okay, something like that. Okay, this is alkane family. Okay. Hello guys, the single bond ends with A and E. So the formula will be CnH2n plus 2. N is the number of moles, okay? Something like that. Okay, or the amount of substance, okay? Mole is the unit of the amount of the substance in chemistry, okay, like that. So the N, 2n plus 2 are all subscript. Right, subscript. You know subscript in mathematics, and then the coefficient is in the side, which is equal to 1. Okay, like that. So we take an example for propane. Propane. Propane gas is a compressed gas. Okay, propane. So there are 3 carbon atoms and 8 hydrogen atoms, and we need to prove really it has 8. We are sure that there are 3 carbon atoms of propane, but we are not really sure the number of hydrogen atoms. That's why we have this basic formula. Go with this. So C3H2 2 times 3 plus 2 is equal to C3H6 plus 2. Therefore, I conclude C3 is equals to H8. Perfect. As propane is C3H8. We substitute that to the basic formula, which is, you will forget, substitute that there, okay, or here. So now we go to the second family, the alkene family, or the double bond, ends with E and E. Go. Alkene. I will never go for the details of organic chemistry. That was organic chemistry is very difficult, really. There are certain explanations that we can never understand because we did not see those structures in our eyes. Okay, the difference of taking up chemical engineering is that we always imagine the number of atoms, the number of moles, the number of protons, the number of neutrons, the number of positrons, or the beta gamma ray, like that. We never see in our naked the wires. Okay, they can see the panel, whether they can touch it and they can see it. Okay, but we can never see hydrogen. Okay, like that. We can only feel that it's hazardous, something like that. Okay, so we always imagine, especially in the nuclear chemistry, you always imagine what is, the fission principles, the fusion principles during reactivity reactions, blah blah blah, so on. So okay, so it's very difficult, really, in taking up this course. Okay, E N E. Okay, Cn H2n minus 2. Okay, so the formula of double bond alkene is Cn H2n minus 2. So let's try, okay, hindi na tayo lalayo. E and E are the last three letters, right? So propene, so we have 3 carbon atoms. I think it's gonna be C3H6. Okay, but let's prove it if it is really C3H6 by substituting the atoms of carbon and hydrogen in the basic formula. Okay, C times 3 H2 times 3 minus 2, so C3 H6 minus 2. Oh, sorry. C3. So I was wrong. It was not C3H6. It was C3H4. Like that. Okay, see? Here is it. C3H4. The protein, the double band protein. And then the third one is the alkene family, ends with Y and E, the triproduct covalent banding, something like that. Okay, the non-polar, like that, banding effect. Okay. So this will be, the theory of that will be applied here. Because Y and E, okay? So Y and E, it's gonna be triple bond. So CnH2n is the formula. CnH2n. So let's substitute now. C3H times 3. Oh, this is C3H6. Like this. Oh. This one. C3H6. Okay. We still prove that to writing the molecular structure. Let's say if the triple bond will exist there. Okay. Now we have the C3H6. Maybe it's wrong also. We don't know. Let's prove it. Okay. So we have 3 carbons. What do you call this one? The Lewis dot structure in organic chemistry, as far as I can remember. Or organic chemistry, this is known as the molecular structures, right? But then in the Lewis dot structures, like blah blah blah, so and so, and you have to react like that, and then shared electrons, blah blah blah, so and so. Okay, I don't think so. I forgot. Okay, carbon, carbon, triple bond. Yes, like this. Oh my gosh. 3, 4, 5, 6. Okay. H, 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 5, 6. 1, 2, 3, 4. Yes, it's really C3H6, the triple band. See? As you can see, the molecular structure of propane C3H6. So they have two carbons. C3H, no, three carbons. Okay, let's prove it. Okay, and then triple bond. Okay, C3, so 1, 2, 3, triple bond. Okay, this one, 1, 2, 3. 1, 1, 2, 3, 4, 5, 6. 1, 2, 4. 1, 2, 4. Hydrogen 6. Okay, C3H6. But I don't think reverse the alkene and the alkene family. Anybody can help? As far as I can remember, this is it. Yeah, this is really okay. Because this formula, okay, I can illustrate very well. It takes me time to analyze. Like that. So let's stick with this basic formula. Okay, go back now to the problem. That was a long introduction, right? But the introduction seems to be complicated. My gosh, what's happening? Okay. Okay, here are the problems. Problem number 1, water. Here's the problem. Okay. With excess oxygen gas. Oh, very difficult. How many grams of carbon dioxide will form? My gosh. Letter B, 0.8 moles of propane. Letter C, if 25 grams of propane reacts with excess oxygen, how many moles of water will be formed? Letter B, if 38 grams of water are produced in the reaction, how many moles of carbon dioxide were produced? So there are 4 questions are being asked in this particular problem. And the moles. Okay, 2 moles are being asked and 2 grams are being asked also. So as we can remember in the chemical calculations of stoichiometry problem solving, first we need to establish the chemical reactions, and then after that we need to balance the chemical equation, okay, something like that. And after that we need to get and cover the mole to mole ratio, the mole to gram ratio, the gram to mole ratio by employing the molar mass, the molecular weight, and the atomic mass unit. Okay, so it depends now in the calculation whether you're going to multiply it directly or you're going to divide it, but ensure that you have to cancel out the unit so that you can get what is being required. To simplify what is being asked and to target the exact answer particular question being asked, right? Something like that. Do this in a systematized manner so that we can solve comprehensively what is being asked. Because if we do this very fast, and it will confuse us what are the best thing to do, or what are going to be the conversion factors to be used in terms of the molar mass and atomic mass unit, something like that. It's going to be enjoyable, okay, for this. But we don't need to refer the periodic table because propane, the components of propane are only carbon and hydrogen, which are very common in chemistry, right? So it is not really complicated because I said before, memorize the atomic mass unit of those elements that are very common, that are being used all the time in the discussion of chemistry problem solving, especially in the stoichiometry and the chemical calculations. So in this problem, we need to be careful. Though this is not too hard, but it seems to be complicated because there are a lot of questions that are being asked. Okay? So all we have to do is to balance the equation properly. But take note on the problem number one that it is not discussed or being presented chemical reactions automatically. Okay, so it creates confusion because it doesn't show the chemical reactions. We are going to make our own chemical reaction basing to the word problem stated in this problem number one. Okay, let's himay-may, something like that. We need to himay-may as we go along the way. So it's in one particular problem. Okay, so that we can interpret well, we need to analyze the grammar also and what is being asked, something like that. And then combine it, and then we can easily understand what is being asked. Okay, go. Like that. Okay. Though I speak too fast for you guys, then if I'm talking very fast, then raise your hands and allow me to slow a little bit, something like that. Okay. Okay. Now I'll use the microphone so that they can hear my voice. Okay. Okay, this is word problem. I don't like also because it's not. I want the chemical reactions will be there automatically because it requires and okay, we need to do a process like this, blah blah blah, so and so. Okay. Question number one: propane reacts with oxygen gas to form carbon dioxide and water. Okay, so the two compounds being mentioned are very important in our daily life. Without carbon dioxide and without water, we cannot live in this contemporary world. We will die, absolutely, without water and without carbon dioxide. So we need to be alert and vigilant to the importance of this water and carbon dioxide. Okay? Because our blood we have to exhale that one and the blood will receive that. And the free cycle, it will release oxygen to the atmosphere in which we will breathe it again and inhale it again. And then it will produce chlorophyll in the process of the photosynthesis. As you can remember, right? So it is the reverse of the combustion. Chlorophyll, you understand the process of photosynthesis because there's a heat of the sun, then it will produce chlorophyll plus oxygen gas in which we breathe the oxygen and we will live. Without oxygen, we will die. Everything will die. Something like that. So it comes from the water. Okay, because water has a number of atoms and it will produce oxygen gas, something like that. And the chlorophyll is very important because it is a source of protein that we are eating day by day in our life. So we will become stronger, stronger, and stronger, and we will live in this world if we are trying to obtain protein through those chlorophyll that are coming from the plants, something like that. Okay, so going back to the carbon atoms, 3 atoms of carbon, C3, and 8 atoms of hydrogen, C3H8, something like that. Reacts. So reacts mean plus. See, there are also words, then we have to interpret it mathematically. The 4 operations, the basic operations of mathematics are multiplication, okay, division, subtraction, and addition. Addition, subtraction, multiplication, and division. Okay, so usually in the stoichiometry, these 4 basic mathematical operations will be used, okay, as we go along the way in the solution. Okay, plus. Reacts means plus. Okay, take note. Reacts plus. Okay, to basic understanding with oxygen, so oxygen gas. If we speak about oxygen, this is also a little bit confusing. Okay, when we speak of oxygen, when we do the reaction, it's automatically mean oxygen gas. Because oxygen exists as a gas, it will never be exist as a liquid. That's why we need to specify the form and the state of oxygen during the chemical reaction. And then we have to state that it is an oxygen gas because solid, liquid, and gas are the phases of matter. Then we have to specify the phase of an oxygen. That is oxygen gas represented as O2 or the subscript 2 after oxygen dioxide down below the oxygen. Too much talking. Oh my God. Okay, oxygen gas. Don't be, don't say like that. You should put two because that is oxygen gas. Oxygen gas represented as O2, not oxygen alone. Okay, like that. So see, that's the difference. If the problems will state the reaction immediately rather than word problem in which you think what are the reactions will be coming from the reactants in the products. So me personally, I don't like also. Okay, propane reacts with oxygen gas to form. So mathematical operation will be equal. So every words have equal in mathematics. So every words in English have equivalent operation in mathematics. So to form equals. Okay, two horizontal line equal. Okay, so you have to be alert also with the words and phrasing. What is the equivalent mathematical operation somewhere along the way? But don't worry, it's been discussed also in your subjects in algebra. Okay, so to form carbon dioxide and water. If you don't love chemistry, you'll confuse what is dioxide. Okay, like this. Di means two. Okay, di, tri, tetra, like that. Penta, hepta. Those are perfect understood and to be easily written and to be easily recognized with. Okay, that's only the purpose. Okay, di, tri, tetra, mono, hepta, eta, mega, prefixes. Prefixes in mathematics will be also applied in the prefixes of chemistry. So it is complementary with each other. Okay, that's why algebra is the like carbon dioxide plus water. Okay, like that. So here's the our. So first, we need to identify, we need to the formula being used. Propane plus water. Okay, what type of reactant? Anybody? Okay, from the four types of chemical reaction in chemistry, this belongs to fusion reaction or the combination or the synthesis. Okay, as I discussed a while ago or yesterday, we have four types of chemical reactions. We have the decomposition reaction, the combination or synthesis, the single displacement, and the double displacement chemical reactions. Okay, like that. But this is an example of a combination in which propane combines like that. Okay, combination reaction. Okay, since this is hydrocarbon, so this is called a combustion. Meaning to say, always applying an exothermic action throughout the chemical reaction. Meaning, heat is being applied throughout the reaction. Exothermic. Remember that one also. The exothermic, something like that. Okay, specific capacity, like heat capacity, something like that in thermodynamics. But we are not dealing with thermodynamics here. We are only dealing here with the general chemistry. Okay, the topics of stoichiometry and chemical calculations, because this can be used also in higher chemistry. Okay, this can be used also in, for example, in the heat transfer, right? In the evaporation, in the crystallization, in the distillation, okay? Fractional distillation, okay? Momentum transfer, fluid transfer, transport phenomena, physical and chemical separation processes, something like that, or even in biochemical engineering or biochemistry. Okay, a combination of biology and chemistry. So it is biochemistry. Okay. Like that. So this is very basic chemical calculation stoichiometry. Okay, like that. Okay, we have to balance the chemical equation before proceeding to solve what are being asked in the particular problem. Okay, let's start one by one. Carbon. Oh my gosh. Sorry to that, okay, I talk very fast. Carbon 3. Okay, reactant means the left side of the equation, and the product is the right side of the reaction. Don't be confused, okay? Only words or terminologies. Okay, the product is CO2 plus carbon here is nothing. So we need to put 3, okay, because it is nothing. Like that, okay, 3. So look at this now. Carbon first. Since there is 3 atoms of carbon on the reactant, we have to put 3 as a coefficient of the carbon, the CO2 in the product. Okay, so it's the carbon atom. So right, and oxygen here in the left corner, where the reactant is 2, right? 2, like this. If the coefficient is not mentioned, my friend, that is automatically 1, equivalent as 1. Okay? If it is not mentioned, if there is no numerical figure, that is automatically 1. That's why we need to times that to the subscript. So coefficient times subscript is equal to the number of atoms. Since there is no numerical figure beside that element or compound, so it is automatically a subscript will be equal to the number of atoms. Okay, oxygen gas, carbon dioxide, and carbon dioxide and the water. So oxygen are present in both compounds. Okay, so we have to add that one. First, in the CO2, the oxygen will be 3 times 2 is equals to 6. And then in the water molecule, we have only 1. Okay, 1 times 1. Actually, we don't have to specify, like it's also 1, automatic 1. Okay, 7. Oh my god. Okay, how can I do this? Okay. Imbalance, right? Oxygen 2 and oxygen 7. Okay, it's headache already in the oxygen. Okay, now we go to just stage 4. We try the hydrogen because we know this is very balanced, right? We don't need to force yet, okay, because this is very imbalanced. The oxygen in the reactant needs fighting. Oh, equality talaga. Okay, it's more complicated than oxygen. Okay, hydrogen, and then we can adjust later on, okay, or choose among them, okay, later. If it is also complicated with the hydrogen, right? Okay. Hydrogen gas is A in the reactant, and the product will be 2. Oh my gosh! Diba? Nag-enjoy ba kayo in the first place? The reactant is the hydrogen is 8 and the product of the hydrogen is 2. So we have to add 6 atoms of hydrogen in the product because that side has a deficient, insufficient number of atoms of hydrogen, not equal to the number of hydrogen in the reactant. So how can we do that? Plus 6, right? Plus 6. So 2 plus 6. Okay. I said earlier a while ago over and okay, that the total number of atoms or the individual atoms in the reactant will be equal to the total in the product. Okay. So the hydrogen A, okay, A, basic mathematics. Okay. A is equal to, okay, equal because this is equilibrium. You know, equilibrium over, so we need to put equal always in order also to solve the variable what is being asked, right? The A is equal to, now try to consider the, okay, the hydrogen in the product. It's only in the molecule of water, right? So as I told you earlier, the coefficient times the subscript. Okay, let X again, over and over again. Let X the number of moles of hydrogen. Okay, so X times 2 or coefficient times the subscript. So X times 2. Okay, X times 2. So do the math. Do the math. Basic mathematics, even elementary can get this. Okay, X is equals to 4. Okay? X is equals to 4. So we have now 4 our number of moles is 4 moles. And then we put the moles in the side of water because we said coefficient. Because coefficient should always be in the side of the compound, or it should be side of the element. So we put the 4 in the besides that one. Okay. Hydrogen in the reactant and hydrogen in 8 outside the product is balanced. Immediately balanced. Okay. Now going back to oxygen. Okay, another reference and balancing. So let's erase this first balancing of oxygen to a new balancing oxygen because we now obtain the hydrogen atoms. So oxygen to broken to my heart. So see, 3 moles of carbon dioxide. So 3 times 2, 6 oxygen atoms. Okay, from the compound carbon dioxide. So 6 oxygen. Okay. Sorry for my illustration. It's a little bit messy. Okay. Oxygen here, right? Oxygen gas. So 6 from the carbon dioxide. Water molecule is only 4 times 2, 8. 8. So 6 plus 8, 14. Okay. 14. 6 plus 8 is equals to 14. And now, the reactant is only 2. Right? 2. So how can I compensate the 2 to 14? So, we will multiply directly with 7. But that is not the principle behind it. Because you just multiply, just to compensate it with 14. But there's no theory behind for that. Okay, we need to understand the theory that the number of atoms of oxygen is equal to the number of atoms of oxygen in the reactant. So again, we need to let the value of X as the number of moles of oxygen gas again, or we can say let Y as the number of moles of oxygen is equals to the number of atoms of oxygen in the product, because we already represented also X in the hydrogen, but that would not matter at all. Okay, so that's only representation. That is hypothetical. This one, jargon. It's only used for representation to better understand the equation, something like that. So let X again the value of moles of oxygen gas. So again. So X times 2, the reactant for oxygen, right? So coefficient times square, X times 2. Okay? The technique is you don't have to touch other elements because you are only touching of half oxygen combines in it. Okay? So X, basic mathematics, let's do the math. Okay, X is equals to 7. Okay, so X times 2, the number of atoms of oxygen is equals to the total number of atoms of oxygen of the product, which is equals to 14. So do the math. X is equals to 7. 7 ba? Okay, 7. So where can you put the 7? Of course, to the reactant that we left the number of X. To the element that is stand alone. You mean by stand alone? Solo moment. Something like that. He is solitaire. He acts alone. That is not in the compound. Okay? Because sometimes also oxygen is present in the compound. Do not be confused with that. Do not let X there. Just always do the let X in the solo alone oxygen or the solo alone hydrogen, something like that. Remember that one. Just let X or let Y, the number of moles in the coefficient, to the element that is solo alone. Okay? So in this manner, so we need to put the 7 in the oxygen gas. So that is 7. Okay, now balance again for the third time. Imagine we are balancing these equations for the third time. Get directly the right. Never touch the carbon anymore. Oh, let's combine there. Sorry. Balance again the carbon, right? Of course. Okay, another paper, another scratch paper. My God. Okay. To those who don't issue that much, you will enjoy. Okay. Okay, carbon. Okay, I need to rewrite the final balance equation. So propane C3H8 plus 7 moles of oxygen gas is equal to 3 moles. By the way, guys, why I do the vloggings of academics? Because I need my brain to be sharpened. I don't want my brain to be stuck, again, to be obsolete. Because I want to, to sharpen my mind, thinking of something that is relevant of what is happening in our daily lives. We can still use this also in our daily lives. Okay, this is very useful. Okay, like that. We will meet oxygen gas in the road, something like that. I mean, we breathe oxygen. Oh my gosh. Okay, something like that. Okay, and then we need to refresh our minds also, and I need to measure also my academic retention, something like that, in my elementary, high school, and college education, something like that. Okay, so this is gonna be the balance equation. I will ask you. Okay, you also balance or not? Or you're only watching? Okay, just do the comment later on, and then just correct me if I'm wrong. Okay, I will be happy to correct it because that's normal. Okay, because you have to accept your limitations and you have to accept the mistakes. Because if you don't accept the mistakes, then you are not professional. All right, that's it. Okay, so carbon 3 and carbon 3 also on the other side. C2H8. Carbon 3, carbon 3. Okay. Hydrogen 8. Hydrogen 8. From the left side and the right side. Okay. And the last two will be the oxygen. In oxygen will be, oh, it's interesting. It's very exciting. Will it be 14? CO2. Take a look. Oxygen gas. So, gas. Oxygen in the water molecule or the water compound will be equal to 4 times substitute 1. It's understood to be 4. So 6 plus 4, something like that. 6. Okay. So it is not balanced. How can we do this? It is not balanced. How can we do this? Anybody? Anybody? So again, we go back. Okay, that's it, because it's actual. Okay, that's it. So we need to compensate another 4 of oxygen. Okay, like that. So another 4. Okay, another 4 oxygen, huh? He said, because it's 14. Like that, right? Okay, because this is 14 and this is only 10 for the third balancing, and we are assuming that is the final balance equation, but still that is not balanced. Okay, based on our discussion to you. Okay, like that, because this is on the spot. Okay, that's why we need to have a fourth and final balancing. I don't know if it's really the final balancing, right? Because it depends on the situation. Okay, so we have the 14 oxygen here, and then we have the 6 plus 4, we have the 10. Okay, so 14. So the 4 here, okay, you should add 4 here. So this will become 8 now. 8 moles of hydrogen. Because it said plus 4. So that it will become 14 to compensate the 14 atoms of oxygen in the reactant. So plus 4, it will now become 8 moles of water. Oh my gosh. Headache. Okay, 8 moles of water. Really, it's very difficult. Okay. 8. But we do it systematically, as I said before. Okay, like this. Okay. Okay. Now, balance it again. Because you're balancing the oxygen, right? Go back again. The carbon is already balanced. Don't touch it already. So, you know that hydrogen will be affected. So the hydrogen is already 16. Okay. So it's already 16 here. So meaning to say, this 8 times 2. So that will become 16 the hydrogen. So times 2. Okay, like that, times 2. So, like this. Okay, like that. You know that? Okay, like that. See? 2 moles of propane plus 7 moles of oxygen gas is equals to 3 moles of carbon dioxide plus 8 moles of water. Okay, like that. Then we balance again. Carbon. Oh my gosh! Don't be afraid, because if it is not really balanced, you need to balance it again and again and again. Okay? Because science is a branch like that deals with the study of continuous experimentation or continuous trial and error in the laboratory to confirm the theories and principles so that it can come up to certain equations basing on the laws, LAW, discovered by different scientists, something like that. So science is always a continuous experimentation. Then if they will fail, they will have to experiment again, something like that. So that is science. Science is not made by quick understanding, and you can automatically get that one. Sometimes it will reach to how many years, how many after, for example, after Archimedes principle, and then here comes Dalton of atomic theory, something like that. And after that, there is what we call as Arrhenius theory. Arrhenius. Really, there is an Arrhenius theory. That's an example. Okay, through evolution, okay, the scientists will have an upgrade of their discovery through experimentation. Sometimes it will become not accurate anymore. Okay, then they have to change it through trial and errors or experimentation, continuous experimentation. That's all science about. Okay, like it's just the same like this. We need to balance over and over again until such time we can prove the final balanced chemical equation. Because I did not practice this in discussing to you. Okay, I did not practice this and then I discuss, and then of course it will be perfect anymore because I practiced it. I don't practice this before discussing this to you, right? Something like that. So it is really a trial and error. Okay, like this. Okay, my gosh, it's very headache, right? It's very enjoyable. How many now? Fourth balancing. Okay, but I tell you, if it will go 6 times, 7 times, there's something wrong with the analysis of the first and second balancing. I told you something like that. But because normally it will reach only based on the experience, never reach to 5th, 6th balancing. But if it will reach to that level, something wrong with your first and second and third chemical balancing, chemical equation balancing. There's something being messed there, and then you did not, get it properly. Okay, something like that. So we are now in the fourth paman. Okay, last. Let's see. Okay. Oh, my gosh, it's very enjoyable, right? Okay, propane. I hate you, propane. We are still in the chemical reaction, right? Okay, but there are also very expert. Okay, that we can immediately get what the balance equation really is. For example, those are super intelligent, like this, blah blah blah, so and so. Okay, I don't know. They are very quick. Okay, but for us, we are just average students, and then we need to compensate with systematic discussion like this, blah blah blah, so and so, so that we can understand, right? Okay, 2 moles. Oh my gosh, of C3H8 plus 7 moles of oxygen gas, 3 moles of carbon dioxide plus 8 moles of water. Mauni siya. Di ba mali siya balance, di ba? Third, ganon. Third chemical equation balance, but not yet really the final one. Okay? Let's first carbon. Ay, mamatay ko yung carbon. Carbon is equals to 6. On the left side, carbon is 3. How can we compensate this one? So plus 3. Okay. Plus 3 now ang carbon because the efficient is on the product. So plus 3. We cannot put another element, okay? Isolated element, but we can only add 3, so it will become 6. 6 CO2. Like this. 6 CO2. Okay, so 6 carbon now. Gosh, it's very exciting. Okay. Oh, hydrogen. 16, right? Hydrogen also in the reactant is 16. I'm tired. And in the product, both sides are balanced. Oxygen is in. Okay. We can adjust really. And then oxygen here is 6 times 2 is 12 plus 8 is 20. Oh, 20, 12 plus 28. So oxygen in the right side is 20. Okay? Oxygen in the reactant is 20 and oxygen in the reactant is 14. Product 20, reactant 14. So there's a loss of 6 in the reactant, so plus 6. How can we do this to make it 20? So we need to change the 7. Okay, we need to change the 7 to x. Let the number of moles is equals to x for oxygen. Actually, we can multiply it directly with 10. 10 times is equals to 50, but for the purpose of theory and principle, we don't need to do that because that is only automatic. Okay, without any what is it called, logic behind why you multiply that one to make it 20. What's the logic? So the logic is based on the theory and principle. Okay, for the law of conservation of mass. Okay, then x is the number of moles of oxygen gas. So this is 2 times x. Okay, 2 times x is equals to 20 at the product. So 2x is equals to 20. Okay, so do the math. How many times that we will do the math? This is the 4 times, right? And we don't do. This is really the process of the balancing the equation, right? Okay, this is the first time I balance this. This is the first time I think so. X is equals to 10. So the number of 10, you will put 1 here. Change already the 7, so put the 10 up beside that. I hope this will be the final equation. Okay, so we have now the 2 moles of propane plus of water. This is for the 4th time balancing the equation. I don't think so that this is really the process because others will make it direct. You know, shortcut method. But I don't know what's the shortcut method for this. Yeah, really, because I don't practice. Okay. When I discuss, I will never practice. That's why. Sometimes I feel scripted, right? So you should not practice when solving, okay? Because if you practice, then you can always have the perfect one. And they will try to question, oh, why you vlog like that, always perfect? Or like that. So there must be something, an error, slight error, like this. And then somewhere along the way, you need to prove it, why you become any error or mistake, and then go back. It's totally different when you practice it rather than you don't practice it. It's better you don't practice it in order for you to practice and practice and practice. What I mean for practice is really you already memorize the steps and then you discuss to the audience. Okay? But me, I did not memorize the steps. I just only follow the principles and theories behind on it. And then this is actual on the spot. That's why, as you can see, I have so many papers here. So, right? Because if I memorize everything, then there's only one paper and go direct. This one, like this. So this is not scripted. Okay? Sorry for that. Sometimes error, right? Okay, I'm not perfect. Explain to the highest level. Okay, like that. So let's redo it in a final paper. This is the 4th time. So 2 moles of propane only for the purpose of discussion or vlogging, sharing of information with sciences courses. Okay, especially the CAS, the College of Arts and like this, blah blah blah, CAS like that. So their chemistry is not higher. So sometimes we need to share the information. 10 moles carbon dioxide plus 8 moles of water. This one, 6. Oxygen 20. Oh my gosh! Oxygen 12 plus 8. Oh, it's already balanced, right? See? Carbon 6, carbon 6, hydrogen. I didn't, I'm confusing. I just follow the steps. I did not get an error, but I'm just confused. Maybe I will be wrong because of too many trials for the balancing. Because normally we can get it by 2 times, 3 times, but it will never reach this far. This is final equation. This is 2 moles. What you will observe this if you are quick enough to comprehend or visualize to the number of moles beside the compound, each compound. As you can see, mathematics again. Okay, so this is not a simplified number of, visualize the number of moles. It goes very higher. It's not normal before talking to you. Okay, so this is not really the normal one because the normal one is already simplified and this is too much number of moles on the side. Even though this is already balanced, okay, but this is not under normal circumstance because too much number of moles of each compound. Then we need to get the, this is still a chemical reaction. We still employ the algebra, we need, or mathematics, least common denominator, least pinakagamay, so that it will be divided to that one, or computation of the grams during on the stoichiometry. We are still on the balancing. We need to divide this by 2. All components left 2. Oh my gosh, it looks like somewhere along here. Okay. Really, this really, I thought it was the same in my first balancing. It's not. This is really the, this is really the steps for this compound propane during the combustion. I think so. Okay. So divided by 2, it becomes C3H8. C3H8 cancels that out, the 2, right? 10 divided by 2 is 5. 5 moles of oxygen gas. 6 divided by 2 is 3 moles of carbon dioxide. And in with the first one, we balanced before. The first one balanced this one. But it is not because there's a 5. The first, there's no still. Where's that one? The first is 7. Okay? We're not sure that is okay? Grabe? Talaga ganito pa yung process niya for this propane. First time. Yes, because I don't even meet this in my college days. Really. Okay, let's go to the problems. Oh my gosh! What's happening? So much. Okay. Oh, really? Sorry for that, guys. It took me 4 time balancing because I really do it in a systematic way. I know there's also a shortcut. I think so. Okay. But I don't want to do the shortcut because I cannot understand why it happens like that way, like this. Because it is, it is fulfilling to understand. But if you just, automatic and shortcut, like, oh, why like, for the purpose of getting the answer only, it's not good. Okay. Really, I enjoyed a lot. Himuot jud ko ang propane. Fairness. Wait for a while, ay Lenovo phone. Talaga. Okay. Oh my gosh. So, we will be using this equation, this one down below, the trick problem that I was announced announcing to you a while ago, announcing grammar. My gosh, everything. Okay, like this. So, if 2.8 moles of propane reacts with excess oxygen gas, how many grams of carbon dioxide will form? So, you need to write the given. It was mentioned. So, this is the solution. Wow, like this. Solution talaga. You have to write, in problem solving, you have to write the solution, the given, the required, something, and then the compatible formula applicable to that certain problem. That's like this, right? And then if you don't know the specific problem for that one, because you will be confused, try to connect multiple formulas. There are also, in rare cases only, in rare cases, there's something like that. As I could remember in the sharing to you, in my third day of the chemical engineering board exam, okay, there's one problem there that I cannot understand really. Okay, I cannot really understand because it was not really discussed. I check it individually. Okay, I check it individually. For example, pressure, volume, the temperature, and then I get the individual formula out of it and I try to connect it, and then I can come up with a new derived equation. Sorry, I have to tell you honestly, that was not discussed in college. Okay, it was discussed in books, I think so, but I don't treat that seriously in that in the library, something like that, because I don't know it will be coming out in the exam or not, right? Maybe it was mentioned, but it is not taken seriously, right? Because we don't know what really comes out. And then I make my own formula, basing on the basic formula, and it took me a long time to do that. That was the last I answered in the third day of the examination. Okay, like that, and what? My gosh, the answer is not also exact to the choices because that was a multiple choice. It's not also the exact one. For example, my answer is only 0.4 and then 0.5 is the nearest to that. Okay, I choose that latter as my answer during the third day of the examination. That was the major, chemical engineering major exam on the third day during the period that I'm okay. I was the last coming out from the room examination, really, for the third day. Person in the chair in the exam for the third day. All are going out now except me who are on the chair because there is still time for that. Others are completing their answers already, but being getting confused. And then I try to check again, blah blah blah, so on, so on. Sure not like this because I did all my best already, and I have limitation. I cannot understand everything, also something like that. And then I go out last, and then Ma'am Engineer Amis Pakamalan, that is the head of the Chemical Engineering Department at the Institute of Technology University, she spoke to me, why you finished everything like this? What you're doing inside? Like this. And I said in Bisaya term, ako yung gitik panikamot na medyo na ako ang tanan yan. Hindi medyo na ako makuan, na-solve yun ako ang tanan. I spoke in Bisaya term for her because she is also a Bisaya teacher. Like that. I was the last came out to that room. Okay? And then luckily, my third day of the examination, which is the major chemical engineering, was my highest on the score. Really. I was lowest in the mathematics because I'm not good in mathematics. Okay? I am good at mathematics, then I can get this immediately. Okay? I can do shortcut like this because everything can be done shortcut if you are just only very good and proficient in mathematics. I'm not good in mathematics really. And then chemical engineering third day was the highest of all the three major subjects in that particular board exam. And luckily like this, I did it, something like that. Okay? So the chemical engineering, which is my major, is also my highest score in the board exam. Okay, and my lowest is all about mathematics, the probability and statistics, differential equation, and then it was also mixed with that engineering mechanics, the strength of the materials also are belong to the general engineering. Okay, First day, general engineering, that is mathematics together with engineering mechanics, structure of materials, like this, probability statistics, algebra, calculus, blah, blah, blah. So the second day will all about physical science, okay? Physical and chemical principles, all about pure sciences, okay? It talks about physics, chemistry, like that, physical chemistry, quantitative chemistry, qualitative chemistry, biochemistry, like that, organic chemistry, like that. All are sciences in the day two. In the day three will be the major, the chemical engineering, and thank God my major was the highest score of my average score in the BS Chemical Engineering Board exam. Okay, something like that. And I'm very happy. Praise God. Something like that. Okay. So make your own formula if you forget or if you don't know what is really the exact equation for that particular problem. So I'm trying to emphasize, okay? Because I really experienced that personally when I talk of the board examination. Okay, that I wanna it's not being discussed. I think it's discussed, but you know, maybe I'm sleeping or what. At that time, it's not taken seriously. I don't encounter that kind of problem, really, for sure. Okay? So going back to stoichiometry and chemical calculations. Okay. So what I understand, if you talk about the Philippine Regulation Commission Board examination, it's more about on proper preparation, and then it's all about stock knowledge, theories and principles, really, okay? Because if you know the theories and principles, you can solve immediately, not immediately, you can understand, apply it in a complicated problems, like that. Because others are only focusing to the problem solving, then their theories are less. Something like, for example, for the theories like this, who discovered hydrogen, like this, then there will be a choices, A, potassium, B, oxygen, C, like that. Then if you have the theory, then you can answer it properly also, something like that. Okay, so because I always go in the library in my break time. Okay, I always in the library. I enjoy in the library, and sometimes I will sleep in the library after reading books. And then I borrowed so many books in going to our place. Every time I will be a student. You are really doing your best. You did your assignment well, something like that. And I don't even go to the city to do videoke or going to the mall, enjoy doing this. I never experienced that in my college. I always within the school campus, and my break time will be devoted to the library, doing my assignments, reading books like that, solving problems, something like that. And sometimes also there are problems there that are exactly the same, not exactly the same. Only the numbers are being changed. Okay, during the board exam, it was only changed, but it's just the same. Okay, I think it was a momentum transfer, like that, the subject, and then it's really the same. Really, the way the paragraph was constructed, it's just the same. Only the given numbers are changed, like that. Maybe it was pattern there. The question, something like that. Okay. So that's it. The proper preparation, read, like that, and then go to the theories and principles, like that. Okay? So you should be balanced, okay? Because others are very good in problem solving, but they cannot answer basic theories like this. What is sublimation, condensation, evaporation? Okay, sublimation, crystallization, evaporation. So those should have definition, and you should understand that one. What's the process all about? You should troubleshoot, or you should determine what's that all about. For example, evaporation. It is the process of blah blah blah, so and so, like that. Condensation, blah blah blah, so and so. Sublimation, blah blah blah, so and so. Crystallization, blah blah blah, so and so. Radiation, blah blah blah, so and so. Thermal insulation, blah blah blah, so and so, like this. Okay, because usually it will never be detailed in the theories. You focus more on the problem solving, especially in college. So many problem solving. Okay, it's become a headache. Okay, really, especially in CIT. Okay, and sometimes I will cry because I cannot understand really, especially the terrors instructors. I cannot understand really. Yes, I can. It's found me difficult. Okay, especially the instructor that is 65 years old, still teaching, like this, and when he discussed, you cannot understand well because he's very intelligent, and you cannot understand that he will. No, his example is very easy, but then during the exam, it's very difficult. You can never answer something like this. Okay, and then you will research the library, what happened like this, and you are studying at the same time you act as an instructor. Do wow, okay, because nobody teaches you. You just read, understand it like this. Nobody teaches you because your instructor is very old, something like that. Okay, my gosh. Okay. Oh, really? Thank you so much. What's happening now? A, no? Okay. 2.8 moles of propane. Gosh. Moles of propane. Okay, grams of CO2. So in this case alone, you should examine the terminology. There is mole, there is gram, so mole to gram ratio or gram to mole ratio. So it will employ the molar mass and the molecular weight conversion factor as you go along the way. Then you're trying to base it also with the balanced chemical equation. Okay? Like this. Your computation will start with the given. Okay, of course. You will start with the known, the measurable one. You should not go to the unknown, of course. You should go first to what is given. Here, given is okay. You start with 2.8 moles of propane. To stoichiometry and chemical calculation, there is no specific formula used. It's just simply, adjusting conversion factor, like this, doing the mathematics, something like that. But there's no such specific equation. For example, volume or density is equals to mass over volume. Work is equals to force times distance. Velocity is equals to distance over time. Force is equals to mass times acceleration. Like that, okay? Efficiency is equals to output over power output divided by power input times 100. There's no such like that. There's no such like that. Okay, maybe later it will still be around the equation or the solution. 2.8 moles of propane. Okay, C3H8. Okay. Now we'll be using the molecular mass, not mass, weight, molecular weight. Actually, weight and mass is just the same. Okay, so I discussed earlier, right? Because the weight considers the gravitational pull of energy, the gravity. Okay, it's considering the acceleration due to gravity. Okay, meter per second square, something like that. Okay, and then in terms of feet, that is 32, like that, like 32.4 times pounds per feet squared, something like that. Okay, 32.4 or 32.1, something like that. Okay, basic. Okay, that's considering the gravity if it is weight. But if it is mass, it doesn't consider the gravity. Since this is only linear, so it is expected that the weight will be equal also to the mass using equally. Okay, because this is not concerned on the gravity. This is not physics. Okay, physics is a branch of science that deals with the study of matter and energy. Okay, and there it's being discussed the motion, the gravity, the acceleration, the speed, the distance, something like that. Something like that. Here is not mentioned that one. There's no such motion in this. Okay, this is only reaction, chemical reactions. Okay, so as you can see, so that's why we say molecular weight is equal to the molar mass. Okay, something like that. But it's not also, it's awkward to say also molecular mass, right? So it's always molar mass. Molar mass and molecular weight, or for single element atomic weight or formula weight, something like that. Okay, actually it's just the same manner, it's just only a terminology. I'm just trying to differentiate, something like that. Okay, so 1 mole of propane in the basic theory. Okay, 1 mole of propane. Okay, 1 mole of propane is equal to the molar mass of propane, which is equal to 3 times 12. Hydrogen is 8 atoms, so 8 times 1.008. Okay, that's 12. And then you have to sum it in a compound. So that will be your molar mass or the molecular weight. Yes. Okay. 8 times 1.008 is equals to 8.064. Okay. Plus 36. 44, oh really? Oh, I don't believe. I will review. Okay. Propane, 3 atoms of carbon, so 3 times 12 is 36. And then 8 atoms of hydrogen, 8 times 1.008 is equals to 8.064. So 8.0, oh my gosh, 8.064 plus 36 is equals to 44.0. Oh, just now I know, I will tell you something. Just now I know that carbon dioxide, which is 44 grams per mole, behaves also like a propane, which is also 44.064 grams per mole molecular weight. Just now I know, really. It's almost have the same molecular weight. Again, the propane has a molecular weight of 44.064 grams per mole. And the carbon dioxide also has 44.02 something of grams per mole. So it's nearly equal molecular weight. So it behaves the same in terms of their weight. It's 44.064. Really? Gosh. Again, review. Okay, 1.008 plus 32. Really, 44. How is now? Meaning to say, this is heavier than air. Because the molecular weight of air is, based on my stock knowledge, is 29 pound per pound mole. 29 pound mole. 29 pound per mole. And that is in pound. And you can convert that to 2 grams per mole. Then you can have also 29 pound, how much grams? So you have also to say that 1 pound is equal to 454 grams. Am I correct? And you can get the amount, okay? From pound to gram and gram to pound. So you can now obtain the molecular weight of air. Okay, so you can now compare which is heavier, air or carbon. So both will occupy in the bottom part of the vessel. Yes, because it is heavier than air, right? It always accumulated downward because it is heavier compared to air. So we can easily detect this carbon dioxide and propane through the gas testing devices. Really? Okay. We use this one since it's most of propane, and then our denominator is also moles. 1 mole, like this. 1 mole of propane, and then this one, 44 grams. Okay, of propane. You can see now the conversion factors. Factor. Okay. Okay, like that. 2 moles of propane times 44 grams propane over 1 mole of propane. You will use this conversion because you can cancel the mole. Okay, what is left is the gram. Okay, like that. Propane, but we are asked the gram of carbon dioxide because we have the moles of propane to produce an unknown grams of carbon dioxide. So we need to establish also to take note the conversion factors of the molar mass also of carbon dioxide. Really? Oh, but this have the same molecular weight. How can I do this? Okay, so, okay, times carbon dioxide. Okay, as I said before, right? 44 grams per mole. Really? 16 times 2. Oh my gosh. 32 plus 12. Yes, 44. 44 grams of CO2. Okay. like that. Okay? 44 grams, it's being cancelled now. So we have the 44 grams of CO2 and mole. This is the conversion factor. So we need to have the grams. And we need to the grams. Remember the molar mass. We have also the formula of the molar mass. Molar mass is equals to the molecular weight times the number of moles. Right? Okay. Like that. Okay. 44 grams. So our it will be cancelled now. Divide. So we can obtain the grams of propane. Okay. Actually, you can cut also. No problem. You can cut. Okay, and you can continue or you can cut. It depends on you. It depends on your, what do you call this one? Your convenience and comfort in solving the problem. Something like that. Okay? So 44 times 2.8. Okay? It's the same space also. Here. 123.2 grams of propane. And then grams of C3H8. Okay. I have now the grams of C3H8. Okay. And then CO2. Okay? CO2. So CO2 will be our anode. Okay. So 123.2. Okay, like that. 2.8 times. Sorry for that, because it's very, dirty. 2.8 times 44, which equals to 123.2 grams of propane. Where's the reaction? It's not a reaction, right? So our reactions, right? So we have now 123.2 grams of propane here. I will write propane. Okay. Now, grams of CO2. Okay. So, 2.8 moles of propane. So, basing on that equation, 1 mole of propane in relation to carbon dioxide, 3 moles of carbon dioxide. Suppose we have 3 moles of carbon dioxide, and then you can get now the grams in terms of molar mass of carbon dioxide like that, okay? 8 times 3 is equals to 8.4 moles of carbon dioxide. So molar mass is equals to the molecular weight, which is 44 grams per mole, times molar mass is equals to, or simply the mass, is equal to 44 times 8.4. 44 times 8.4. 44 times 8. And you have to put that here for the CO2, 369.6 grams of CO2, like this. Like this. So how many grams of CO2 will form? So it is 369.69 grams. 369.6, like that. Okay, this one. This is the solution. Okay, you cannot understand. It's very dirty, right? There's no space enough. Okay, but it's the same principle what I discussed for you later. It's gonna be like this always. Okay, and it's only a little bit tricky, and then you analyze something like that, and then you can get the answer. This is only for the purpose of discussion, right? So letter B, how many grams of oxygen will completely react with 3.8 moles of propane? So we'll start now with 3.8 moles of propane. To take a look at the reaction, molar mass, and cancels it out. So we have the grams already. This is very easy. Easy. Ano ba yan? Okay, letter B. Why easy? Letter B. Propane. We need how many grams of oxygen? Relation with oxygen to produce grams of oxygen. So the relationship in the oxygen in the chemical reaction. Okay, that is the first point to consider. It's their relationship, so that we will not be confused. It's their relationship to be discovered. Like this. We put it moles of CH3H8, and then 1 mole C3H8. Okay, and then for the oxygen, we have 5 moles of oxygen. Okay, so cancels out. What remains is the oxygen gas, and then through the molar mass, which is 2 times 1.08 pila. 2 times 1.08. Oh, 2 times 1.008 is equals to 2.016 grams per mole, or 1 mole is the conversion factor of the carbon dioxide, right? So cancel. No. See? Actually, the conversion factor is 2.016 grams mole, or mole 2.016 grams. Then we cannot cancel out directly. See? So we will divide this one. We will not multiply. Okay? So you need to cut the equation here, and then later on we need to divide. Okay? Or we need to multiply, but we need to reverse this conversion factor, so that what will remain is the grams of carbon dioxide, oxygen gas. Okay? Like that. Okay, 3.8 times 5 gas, and then 1 mole times directly, like this. So I can have now 910 times 2.06. This is also the molar mass formula. Okay, 19. Try to take note also, molar mass, there's a word molar, so that means you take account of the number of moles. Always put that in your mind. If it is molar mass, it has to do something with the number of the term alone. Molar mass, moles. So the presence of moles are very important. Okay? Because if there's no moles, that is not a molar mass. So you could either use the other one, which is density is equals to mass over volume. And then you can rearrange the equation, so it could be now volume is equals to density over mass. Sakto ba? Mass over density. Okay? The volume. Because there are two things to get the mass. It's in the density formula, and it's in the molar mass. Okay, but in the stoichiometry, it's more on the molar mass. Very clear. It doesn't require temperature, pressure, volume. It's always number of moles and grams. So that is also the important thing to consider, to remember. And in stoichiometry, chemical reactions, it's always involved grams and moles all throughout the process, all throughout the chemical reaction. There's no such temperature and volume. Maybe in the future it will be combined with ideal gas law. I don't know what to do. Write another equation out of that, right? Okay. Just like I remember the the Albert Einstein energy, as far as I can remember, is equals to the mass times the velocity, or equate that also with another formula of energy, in which involving kinetic energy in an ideal gas law. So we have 3 halves in RT. And if you have to connect that one, you can you can obtain another equation out of that, and you can cancel the same variable out of it. So what being, you can solve also what is being required there. So it's gonna be like that, the problem solving. Not only that, the energy, a lot, the work, the force, the density, the mass, the volume, like that. Because we think that we have the another topic, we forgot the other topics already. It should be connected somewhere along the way. Okay, like that. I remember in my college days, my instructor gave a problem that ideal gas law, uh, imagine PV and RT. But this question is like this: how many number of tiles to be put in the toilet? See, tiles, the number of tiles, because there is surface area. Okay, we can connect the surface area through the the formula of pressure. So pressure is equal to force over area. Then you can insert that in the PV and RT. So PV is equal to in RT, and then area. If the force is given already in Newton or in kilogram meter per second square, so you can solve for the area. And then since tiles are only basing on the units, okay, how many tiles? Then you have to multiply how many pieces like this. As long as you have the surface area already. Okay, so you can get the number of tiles, of course, by multiplying it directly after you have the surface area. See, they connect that number of tiles in the toilet can be put in the blah blah blah. See, and that's so very shocking, right? So it's very far, but it's still connected because of the area. Okay, like that. And then through that area, we can also compute the diameter. Okay, though the problem is ideal gas law, and then the problem, what is the diameter of the pipe? You can compute that one because of the ratio of force over area. And area is equal to two pi r is the circumference. Okay, and the radius and the diameter is equal to 2r. And then you can determine the diameter, the radius, of course, by the surface area, right? So area is equal to pi r squared in the basic trigonometry. Okay, area pi r over 4. And then you can compute the diameter and the radius out of it, insert that in the ideal gas law. Something like that. Okay? We will be confused because we are not expecting that it should be still carried in that kind of problem because that was a gas problems. So that is only algebra type of problems, or geometry. Okay, like this. What is the perimeter of a rectangular, the parallelogram, something like trapezoid, okay, triangle, something like that. That's geometry, right? Or trigonometry, I don't think I forgot. Something like that. And then you can carry that over to the chemical reactions in the ideal gas law. And then, of course, students will be shocked because your example are not like that. And then when you give exams to the students, you are asking for the diameter. They will be, of course, because the diameter is not being discussed there in the topic. So what the instructor is trying to emphasize, that you should not forget the basic concepts of the other subjects, because you can still connect that to another topics also. It will connect, especially if it has the same variable. Energy, heat is equals to heat, like this. Okay? Heat, okay? And then you can, sometimes heat can be also an energy, something like, because of the unit also. And you'll be confused. There's no heat mentioned, but heat is also an energy, like that. And they will try to trick you through the problem. That's why you will be confused also, because we are always used to that term heat. But actually, it can be used in terms that there's a negative heat and positive heat, sometimes like that. Because when we speak of heat, it's always not negative because it's very hot, like that. The negative temperature is always cold, right? So you will be confused again because you think heat is always a higher temperature, like that. So it should be at a lower temperature and higher temperature. It is still called heat, okay? Like that. Maybe you are referring to hot. That's why it's a lower temperature or higher temperature. So hot will never be cold, of course. Something like that. Okay? And now we have to multiply it. Too much storytelling. Okay? 19 times 2.016. Okay. So we have 38.3 grams of what's this? Oxygen. 38.3 grams of C and D because it's almost the same, principle. Okay, it's up to you guys. Okay, if you have a paper, you can write that. Write down. Letter C is if 25 grams of propane reacts with excess oxygen, how many moles of water will be formed? Letter D, if 38 grams of water are produced in the reaction, how many moles of CO2 were produced? Okay. Okay. Also, it's already the A and B. So in this case, then, if 2.8 moles in A, okay, 2.8 moles of propane reacts with excess oxygen gas, how many grams of carbon dioxide will form? So 369.6 grams of CO2 will be formed through the reaction of 2.8 moles of propane in excess with oxygen. Like that. And letter B, how many grams of oxygen will completely react with 2.8 moles of propane? Okay, it should be 38.3 grams of oxygen, something like that, to produce or to react with 8 moles of propane, something like that. Okay, so as you can see, always moles, grams, to moles, so it is not really that complicated. Okay, what is complicated later is if it will be mixed with other formulas and equations. Activity, something like in nuclear chemistry, sometimes it will be mixed also with ideal gas law, and out of a sudden it will be mixed also with stoichiometry, and that's the time you'll become more headache because it's mixed already there in one problem only. Okay, because it's possible really to connect it. Okay, like that. Okay, okay, guys, it's very lengthy now. At least I solved another example of stoichiometry problem regarding propane reacts with oxygen to form carbon dioxide and water, a combustion reaction of propane, a hydrocarbon propane, or a compressed gas propane. Okay, like that. Okay, thank you so much for listening and watching my much as I did, and I hope you can also do the solving of the problems that there in stoichiometry or chemical calculations, especially if you are BS chemistry or BS chem or BS chemical engineering. Okay, if you're studying now and then your courses are that, then you can use it. Okay, or you can refer so many books in the library for easy comprehension. Okay, or you need to sit at the front of the classroom in how she or he explains it well to the, okay, so you should be at the front so that you can hear properly what the instructors are, and you will never talk too much to your seatmates like this in your classroom. You'll focus and listen to what she or he is talking about regarding to the specific lesson on that day, something like that. Okay, our lesson for today is stoichiometry. Okay, God bless, Baruch. Wow. See you later for my vloggings and love.